Here is example 2 from section 2.2. I want you to determine if this quadratic function, the parabola, if its graph will open up or down. I also want you to find the vertex. I want you to find the y-intercept, make a sketch of the graph, and then tell me the domain and range in set notation. Before we start doing any of this, let's say what a, b, and c are equal to. Now remember, this quadratic function is written in standard form. And this is what standard form is. F of x is equal to ax squared plus bx. I didn't write this in the previous example, so I'm going to do it now. Here's the standard form of the quadratic function. Notice that the letter a represents the number that's in front of the x squared term. So in this case in particular, a will be equal to -2. b is the number that is in front of the x term. The coefficient for x in this case is 4. b is 4. And c is the constant term, which is 3. Now, how do we determine if this function opens up or down? Well, we have to look at a. Remember, how do we know that? We look at the value of a. If a is positive, it opens up. If a is negative, it opens down. So for number 1, I determine that this parabola opens down. Number 2. Number 1 we're done with. Number 2 is find the vertex. To find the vertex, I look for the x-coordinate of the vertex first using this formula, the opposite of b over 2 times a. And that is equal to -4. I used the b that I found as my first step over 2 times a, and a is equal to -2. Now be careful here with the signs. This is equal to -4 over -4. That equals +1. Now remember, our vertex has an x-coordinate and a y-coordinate. When we talk about the vertex, we're talking about the location of it in the coordinate plane. So far, we have found that the x-coordinate is 1. Now we have to find the y-coordinate. How do we find the y-coordinate? You take the original function. You take the original function, f of x equals -2x squared plus b plus 4x plus 3. And what you do is you take that 1, that x that you found, you said x is equal to 1, and you plug it in anywhere there's an x in this function. So this would be -2 times 1 squared plus 4 times 1 plus 3. And that equals -2 times 1, which is -2, plus 4 times 1, which is 4, plus 3. And that will give you -2 plus 4 is 2, and 2 plus 3 is 5. This 5 is your y-coordinate for your vertex. So finally, your vertex is found at this point, at point 1,5 in the coordinate plane. You found your vertex. Number 2 is done. Now number 3, for number 3, y-intercept. In the last example, I taught you that when you have standard form, the y-intercept is simply 0 and the value of c, or the value of your constant. This is your y-intercept. 3, done. 4, sketch the graph. So we're going to sketch the graph and find domain and range. Here I have the coordinate plane. So let's try and sketch this graph. We had said that the vertex was found at point 1,5. Here's 1 and then 5 up. 1, 2, 3, 4, 5. That's the vertex right here. I also know that the graph opens down, so I know it's going to look like an upside down U this way. And I also know that the y-intercept is at 0, 3. So here's 0 and then up 3. 1, 2, 3. Right there. Now I can sketch this graph. So this is going to open down because that's what we had determined. Like that and like this. And there you have the sketch of the graph. Domain. The domain for quadratic functions is the set of all x's such that x belongs to the real number system. What this means is that all the x's on the x-axis will work are valid values for this function. And for quadratic functions, this is always the case for domain. Domain will always be this. Now for range, range is different. Range is what y values. If I were to draw lines like this horizontally, which y values does this function contain? Well, the first y value it has is right here at y equal to 5. Right? At y equal to 5, that's the first value I have. I also have a y value of 4 right here and here. I also have a y value of 3. I also have y value of 2 right here and here. I also have a y value at 1. And if I continue to do this, I can go on forever all the way down to negative infinity. I will have values for y. So the range is the set of all y's such that y is less than or equal to 5. That means that 5 and below are my values for range. I will not have a y value greater than 5. For example, at 6, if you look, there's nowhere to be found. This graph is nowhere to be found at a y value of 6. All y values happen at 5 and below. Okay? So there you have it. I hope you understood.